Yes, sir.
So it was told to me by one student that is finding some difficulty in experiment number 10, which is basically Raspberry Pi board. So the same experiments I will discuss today here, and I will try to demonstrate it here so that you can do it at your home. So this is the document which I placed on the Google Classroom as well as in Microsoft Teams. So this is experiment number 10, which is basically configure Raspberry Pi board, write and execute basic IO programs, read data from the motion sensor, capture image if motion is sensed, and send image by email. So in this experiment I am using Raspberry Pi Model 3 board. It is having a 64-bit quad core 1.2 gigahertz. So this is the board I am using, Raspberry Pi board, and I think this initial part we have already discussed, so I am not repeating. This is Raspberry Pi Zero board. That means Zero board doesn't have a much USB port and many other connectors. So once your program is tested, you don't require this Raspberry Pi module. The same chip is also available in Raspberry Pi Zero. And whatever the peripherals you require, you can easily connect using the IO connectors available here. Introduction part I will not repeat because in earlier talk we have already discussed. This is the connector diagram which we are using to connect the motion sensor. So at present I have connected motion sensor at GPIO 4. In the last lecture I shown you the DHT sensor, DHT22 sensor to measure temperature and humidity. In this lecture I am going to show you the motion sensor, that is a PIR sensor. This was earlier version of Raspberry Pi Model 2. I have it, but it is outdated now, not available in the market. So for you, either you purchase Raspberry Pi 3 or 4. 3 you will get at lower cost, so I recommend 3 because 3 is also having a Wi-Fi and Bluetooth module inbuilt into that. Last time I told you that these are the minimum components you need to start. Either you require HDMI supported screen, USB keyboard and USB mouse, or if you do not have these, even if you have a laptop and desktop, then also you will be able to connect your Raspberry Pi. For model version 2, actually Ethernet cable is required, because in version 2 Wi-Fi chip is not there, but in Raspberry Pi 3 and 4 Wi-Fi chip is there, so even you don't require a Ethernet cable, only you need a laptop and desktop. You don't require any other connectors except only USB cable to power up the Raspberry Pi. So this micro USB cable you will need to give the plus 5 volt power supply, and one SD card you will need. So in a Raspberry Pi, operating system will be there in a SD card. 32 GB is desirable, so that you can store many photographs and videos and many more programs in that. An internet connection is required for Raspberry Pi. Last time I also shown you how to copy the operating system, that is image file, from the Raspberry Pi website. So you can download it from the website and then you can burn it into the SD card with help of a Win32 disk imager. This is a very small software available. You can just Google it, you will find it. You can download this software and then you can use it. So this software will be useful to copy the Raspberry Pi operating system into the SD card, and that SD card you have to now insert into the slot which is provided on the Raspberry Pi board. Alternate way of installation, that if you don't want to use this Win32 disk imager, then you can also use NUBS. This is the alternate way of installation. The full form of NUBS is New Out of Box Software. NUBS is an easy operating system installation manager for the Raspberry Pi. You can format the SD card, extract the files from the NUBS zip file and copy that into the SD card, just like you are doing copy and pasting of other files. Similar way you can do it with help of a NUBS. So on the first boot, the recovery and FAT partition will be automatically resized to minimum, and a list of operating systems that are available to install will be displayed. And to get the remote access of RPI, so now I will show you how to remotely access the RPI. But for that remote access, you need to install XRDP in your Raspberry Pi board, and to install the XRDP that is required for the remote desktop connection, that is one kind of a protocol. So to install that, what you have to do is sudo apt get install XRDP. This command you have to run on the Raspberry Pi after the first booting. Then it will install the XRDP. Once you install the XRDP, you will be able to access the Raspberry Pi from the remote location. So for example, I will show you. I have connected this Raspberry Pi screen. Is this Raspberry Pi screen visible to all of you?
Yes, sir.
Okay. So see, this is showing 192.168.1.101. This is the Raspberry Pi screen. So I will disconnect it and will connect it again, so that you get the idea. So what I will do here I will start remote desktop connections application. So this application is by default available in all Windows operating system as well as on Linux operating system. So this is a remote desktop connection. So why we are using this remote desktop connection? Because we want to connect Raspberry Pi with our laptop. So as I know that my Raspberry Pi is having IP address 192.168.1.101. So I will write the same address here. If my Raspberry Pi is having some different IP, then the same IP I will write here, and then I will connect. Once I will connect, it is giving me one window. In that it is asking login to XRDP. So in this case we have to provide username and password. So by default username of Raspberry Pi board is a Pi, and by default the password of Raspberry Pi board is RASPBERRY, that is Raspberry. So that is a by default password, and when I will click on the OK, I will be connected to my Raspberry Pi board. So this is actually screen showing Raspberry Pi board, and this is actually operating system, where you will get the menu here. It is based on the Unix operating system or a Linux operating system. So menu is slightly different than the menu available in Windows operating system. This is actually programming softwares are available here. Node-RED, Python 2, Python 3, etc. All these softwares are available here. So like this, this is actually kind of a installation. Then suppose if you want to write a program, then you can open either Python 2 or Python 3. You can write a different programs, and you can execute all those Python programs here. So last time I shown you the program which was actually for GPIO operations. I will not repeat that portion again here. Just I will skip few slides and okay. Now this is very important. There are two ways to access the GPIO pins. One is a baud mode, another one is BCM mode. When you use the baud mode, then pin number of connector you have to use directly. And if you are using BCM mode, then you have to refer the GPIO channel. I will show you one example. For example, here I am importing GPIO module. I am importing time module, and then I am setting GPIO.set mode, GPIO.baud. So I am setting the baud mode. So whenever I am saying baud mode, and whenever I am writing here 3, that means it is a pin number 3. It is not GPIO 3, it is a pin number 3 of the IPR board. So if I will show you the pin diagram, so in that case it is actually this pin number 3. So at pin number 3 actually it is a GPIO 2. So now if you specify BCM mode, and if you specify 3 there, then it is GPIO 3. It's not pin number 3, it is a GPIO 3. So there are two modes. If you are using BCM mode, then you have to refer this number GPIO 2, GPIO 3, GPIO 4 and all that. But if you are using baud mode, then simply directly you can refer the pin numbers on the Raspberry Pi connector. So that is a that is the thing you have to keep in mind. Otherwise, what you will do in your program, you will write the 3, and if you connect the device at GPIO 3, then it will not work. So if you are specifying here a baud, then compulsorily you have to connect your GPIO output device with pin number 3, not on GPIO 3. So this is a very important pin concept that you have to remember. I think everything visible. Am I audible? Is there any issue? દેખાય છે, સંભળાય છે. Okay, fine, good. So this was a very simple hello world program to blink the LED. I think I have demonstrated it last time. It's very simple program. Just simply we send high and low signals to the GPIO, right? Okay, let me switch back to the manual. So these are actually whatever I have splashed on the PPT. The same thing is written in this experiment number 10. Then the process of installation of operating system is also explained in detail in this experiment number 10. There are two ways are shown. One way is using Win32 disk imager, another way is using a NUBS. Then the procedure to get the remote access is also explained here, which the procedure you can follow. So on the first time you may need the LED monitor. So all of you have, if you have a TV at home and HDMI connector is available at home, then Raspberry Pi is also having a HDMI connector. So you can use HDMI cable to connect Raspberry Pi with your TV. And once you switch on the Raspberry Pi, you will get the Windows screen, and then when you open the terminal, so there is one shortcut is also available, Control Alt and T. If you press that shortcut, then also terminal will be available. And on the terminal you have to issue this command, sudo apt-get install xrdp. Once this will be ready, you don't require further now television. Now you will be able to use your laptop or a PC to connect with the Raspberry Pi. So this is the procedure, and if you want to permanently give the SSID and password, then you can modify this file which is given on the path etc network. So that file is basically command line.txt file, right? So you can append that file, as well as you can also append the interface file to permanently store the SSID and password in the Raspberry Pi, so that frequently you don't require to give it again and again to connect your Raspberry Pi with the Wi-Fi point. Then you can access GPIO pin, as I told, baud mode and BCM mode. This is the first program which I already explained you. This is simple hello world program which will just make LED on and off. The second program is related to the motion sensor, PIR sensor. So if somebody is near to PIR sensor, then it will sense, and camera is connected with the Raspberry Pi. So camera will capture the photograph and it will send the email. Whatever the email address we are specifying in the program, on that email ID the photograph will be taken and it will be sent by the Raspberry Pi board automatically. So in that case, what we can do here, the same program, import rpi.gpio as GPIO, import time, import numpy as np. All of you have already studied, those who have opted Python are familiar with this, the numerical Python module and numpy. Then CV2 is actually computer vision library available in the Raspberry Pi board, because here we are going to capture the photographs. So for that purpose we require a computer vision library. Then this is actually again for the timestamp, so date time and import date time. So actually what we want to do is that at what time the person has came, the timestamp will be also sent. Then we are importing the operating system. Then we import the SMTP library because we want to send the email. Then MIME, multipurpose internet mail extension, that is the full form of MIME. So basically this Google is using MIME actually. So for that purpose we are importing the required library for the MIME. The Gmail user from where you want to send the email, at present I am using here ecgecr@gmail.com. But if you want to send it from your email ID, you can specify your own email ID here. Then you can specify your own password, because you have to give the password in a program. Otherwise, your program will not be able to connect with your email server and it will not be able to send the email. So email password you have to set here. Then to whom you want to send the email. So the receiver side email ID you can put it here. I have put intentionally here chvitlani@gecrajkot.ac.in, and the subject is a snapshot of your workplace. So whatever the subject you want to write here, you can modify the text. And one more text is written here, that there is some activity at your workplace, observe the attached image. So if somebody is coming near to the PIR sensor, it automatically takes the photograph and send this message along with the photograph. So message is standard, there is some activity at your workplace, observe the attached image. So you just observe the image, and if everything is fine, you can just ignore the message. But if something is different, then you can take the action, whatever the required action you want to take. So here sensor is equal to 11. So in this case, if I write here that sensor equal to 4, then I have to connect my Raspberry Pi at pin number 4. If I am writing here 11, then I have to connect my sensor at pin number 11, because I am using here board. Right, our mode is a board mode, so directly I have to connect my sensor at pin number 11. Now I will show you the PIR sensor diagram. I have actually searched in a Google, so the same thing I will show you here. Let me check it here. Okay, I think this is the PIR sensor, and this is the connector diagram which is given here. VCC, then data output and ground. So these 3 pin you have to connect. VCC with the VCC of Raspberry Pi, ground with the ground of Raspberry Pi, and output you have to connect at pin number 11 of Raspberry Pi. So this is known as a PIR sensor, and popularly it is also known as a motion sensor or a motion detector. Right? It's a very low cost device available easily in the market. So this is how it's look like. So this is actually if you are connecting somewhere this sensor, then that sensor you have to is an input device. So sensor and then GPIO.in, because it is an input device, and GPIO.PUD, that is we want to connect the pull-up register, right? So pull-up register we are using. So internal pull-up register is already available, so you don't require to connect the external pull-up. So for that purpose, to activate the internal pull-up register, we are giving this option, right? And pin number 3, some output device we have connected. So for that purpose, we are declaring it as a GPIO.out. Then what it does, sensor status is equal to GPIO dot input sensor. So basically it sends whether your PIR sensor is giving high signal or a low signal. So by default it will give the high signal. If someone is coming near to the PIR sensor, then the PIR sensor will provide the active low signal, right? So here we are using if else statement, right? If else statement, in that what we say that if the sensor status is this, then door is closed. You can also display some other message if you want to display it locally, that nobody is there. You can specify, you can always change this message, nobody is there, right? And GPIO output pin 3 low, so that means there is no alarm. Then suppose if that signal is not high and it is low, then what it will do, the door open alert message or whatever the message you want to display, that same message you can write it here. Then you can energize the alarm, so GPIO will be high. The camera will take a photograph with help of this command cv2.video capture 0. So 0 is the channel at which the camera is connected. The frame it will read and it will save the photograph. At the same time, it will also save the time and date in this format: year, month, day, hours and minutes. Then it will store this file with this file name. That means what it will do, it will take this as a file name, date, time, and that means year, month, date, hours and minute will be taken as a file name, and .jpg will be attached with that, and that file will be sent to the via email, and then that will be attached here. And these are the actually commands to send the email. So in this command we are saying that from this Gmail user and to this Gmail user and subject. So whatever the subject and everything we have already defined here, right? Everything is we have defined here. To is this, subject is this, from is this. So everything we have already defined it here. So the same thing we are doing here. And these are actually some commands basically to encode your message, because normally email is using encryption, right? So we are using some encryption here, and then we send this message, and then our server is a SMTP server, because Gmail is using SMTP server and port number is 587. So the same port number you have to specify here, and then we have to start sending the message. So these all commands are basically to send the message, and once the message is sent, it will also print the message that email is sent. So this is how you can write the program in a Raspberry Pi. The same program is given in your lab manual. You can just copy and paste this command program in Python, and then just you can read it, right? So this is how you can do the experiment number 10. Then there is some modification you have to do in a worksheet. So it's very simple, modification is very simple, that you read the digital sensor. So how you can read the digital sensor? These are the command to read the digital sensor, right? These are the command. This is the command to read the digital sensor. So you can take this command to read the digital sensor, and you have to glow the LED connected to pin number 3. That is also very simple, because the glowing LEDs you will get it here from here, right? So this will glow the LED. So just you have to go through this program 1 and 2 and try to write this exercise yourself, right? So that is a part of your worksheet. Write and execute program for 3 LEDs connected at 1, 11, 13, 15. So there are 3 GPIO pins where you have to connect the LEDs, and you have to write simple program to glow these 3 LEDs one by one. And that is also very simple, because what you have to do here, you have to define all these 3 pins as an output pin here using this command, and then simply one by one all these 3 pins you have to send the high, low, low and all kind of possible combinations here. So simply you have to modify this program. This is written for 1 pin. This same program you have to rewrite for a 3 pins. It's very simple. I think you will be able to do it. Then third exercise is, if you want to control the electrical appliances which is operated by 230 volt AC, supply with a Raspberry Pi board. How you will connect these appliances with pin number 3 of Raspberry Pi board? Draw schematic diagram. So here you have to draw a schematic diagram with help of a relay driver. So you can use a transistor as a relay driver. You use one relay, and with the contact of relay you connect the electrical appliances. So that's also very simple, I think. So is there any doubt in this? Will you able to perform this experiment number 10? Is there any problem? If you have any problem, you can ask me.